180 degrees, whereas congruent angles have equal measure. Let's get started. Problem 193. Suppose angle A in the diagram at right measures 48 degrees. Use what we know about angle pair relationships to determine the measure of angle B. Okay, so angle A is 48 degrees. Therefore, the angle corresponding to A must be 48 degrees. We learned that last class. And since B is vertical to that angle, B must also be 48 degrees. Corresponding and vertical. Part B. Julia is still having trouble seeing the angle pair relationships clearly in the diagram. Her teammate, Altea, explains, hey, when I translate an angle along the transversal, I notice its image and angle B are a pair of vertical angles. That's how come I know that angles A and B have to be congruent. So Althea is translating the angle A across the transversal. And then because the translated version is vertical to angle B, all of these angles have to have the same measure. That was our version of doing tracing paper, everybody. Next, I'll start with angle A each time to decide whether angle A and B are congruent or supplementary. I'm going to translate angle A down to a corresponding angle, and this angle is supplementary to angle B. Translating A to its corresponding angle. I know because translating A to its corresponding angle shows a supplementary relationship. Number 2, I'm going to start with A, and then I'm going to translate it to its corresponding angle. And that corresponding angle is vertical to B, so these angles will be congruent. I know because the angle corresponding to angle A is vertical to angle B, and vertical angles are congruent. Okay, last one. I start with angle A. I translate it to its corresponding angle. And now I see that A and B must be supplementary. I know because the angle corresponding to angle A makes a straight angle here with angle B. And straight angle pairs are supplementary. Problem 194, alternate interior angles theorem. In problem 193, Altea showed that the shaded angles in the diagram are congruent. These angles are called alternate interior angles. They are called alternate because they are on opposite sides of the transversal, and interior because they are both inside, that is, between the parallel lines. Question: is there another pair of alternate interior angles in the diagram? Answer: yes. Right here is where I'll start. I go to the other side to get to alternate, and I stay inside the parallel lines to remain interior. This is angle DCF and angle EFC are also alternate interior. Think about the relationship between the measures of alternate interior angles. If the lines are parallel, are the alternate interior angles always congruent? Are they always supplementary? I think they're always congruent because we didn't use any numbers, so we proved a general case. Let's make the conjecture. If lines crossed by a transversal are parallel, then alternate interior angles are, I'm just going to say it, congruent, period. Part C. Instead of writing conditional statements, Roxy likes to write arrow diagrams to express her conjectures. She expresses the conjecture from part B as lines are parallel, arrow, alternate interior angles are congruent. This arrow diagram says the same thing as the conditional statement we wrote in part B. What do you think the arrow means? It means the word then, or therefore, or so, or so it follows. Lines are parallel, then alternate interior angles are congruent. Lines are parallel, therefore alternate interior angles are congruent. Anything along those lines. Now we're prove that if parallel lines are crossed by a transversal, then alternate interior angles are congruent. Okay, I've drawn the diagram, and I'm going to use rigid transformations to map CFG onto BCF, which is the definition of congruence at its most basic form. So the very first thing I'm going to do is 1, translate angle CFG to angle ACD to show that angle CFG is CFG is congruent to angle ACD, and they should be because they're corresponding angles. So here I have angle CFG, and I'm translating it right up to ACD, and they line up perfectly. Successful. Next, I'm going to rotate angle ACD about point C 180 degrees. Now I actually don't have the ability to do rotation with the app I'm using, but hopefully you can picture it. If I were to rotate this 180 degrees, it would end up right here. So we have to use our imaginations a little bit. It would line up perfectly. And therefore, I would have a list of rigid transformations, just 2 of them, that mapped CFG to BFG. Therefore, I would have angle CFG is congruent to angle ACD, which is congruent to angle BCF. And that would allow me to say, therefore, angle CFG is congruent to angle BCF. period. And if you noticed right here, I should have done a G symbol and I wrote a C, so go ahead and make that correction, please. That's our proof. Next, 1-95, same side interior angles. The shaded angles in the diagram have another angle pair relationship. They are called same side interior angles. Why do you think they have this name? Did you think about it? They have this name because they are on the same side of the transversal and they are interior to the parallel lines. What's the relationship? Well, it's either congruent or it's supplementary. Let's do the translator. I'll start with angle FCD and I'll translate it. Oh, look, it makes a straight line pair. They're supplementary. Okay, let's write a conjecture. Lines crossed by a transversal are parallel. Therefore, that's what the arrow means, remember? Same side interior angles are supplementary. Part C. Claudio decided to prove this theorem as follows. He used letters in his diagram to represent the measures of the angle. Then he wrote A plus B equals 180 degrees, and A equals C. Is he correct? Why, yes, he is. Although I don't know where those letters are. Let's add them. A plus B is 180, and A equals C. A, B, C. I know because angle A and C angle C are corresponding, so congruent, and angle A and angle B are a straight line pair. So add to 180 degrees, period. Let's finish that proof using the letters as I've assigned them. So 1, angle A is congruent to angle C since lines E and G and B, D are parallel and angle A corresponds to angle C. 2, angle A plus angle B equals 180 degrees since they form a straight line pair. 3, based on 1 and 2, I can say that angle C plus angle B equals 180 degrees, and therefore angle C plus angle C and angle B are supplementary. Period. Done. A, B, and C were arbitrarily assigned So this works for any values A, B, C, as long as they fit the diagram. Therefore, same side, interior angles are always supplementary. Next problem. Alternate interior angle practice. We're going to solve for the unknown value here. Okay. Here I have alternate interior angles. Okay. Next problem. These are not alternate interior angles. These are corresponding angles, and therefore they are congruent. So I'll set the two expressions equal to another. 5x plus 13 equals 58. I subtract 13 from both sides, which gets me 5x is equal to 45. Dividing both sides by 5 reveals that x is equal to 9. Almost done. We just have to summarize our learning with a graphic organizer. Our vocabulary follows: transversal, a line that crosses parallel lines to create congruent and supplementary angles. Congruent, having the same measurement. Supplementary, angles adding up to 180 degrees. Now we're going to go over angle pairs and parallel lines cut by a transversal. I added arrows because this diagram should have shown that we have parallel lines. Corresponding, angles that lie on the same side of the transversal and on the same side of parallel lines. These angles are in the same and they are congruent. Next, we have alternate interior. We are interior to our parallel lines and on either side of the transversal. These angles are also congruent. Next, again, we're on either side of the transversal, so we are alternate. But this time our angles are exterior to the parallel lines, and we call these alternate exterior. Again, these angles are congruent. Next, now our angles are on the same side of the transversal. We call these same side, and these angles are interior to the parallel lines, so we call these same side interior. Same side interior angles are supplementary. Next, we have angles that are again on the same side of the transversal, so same side. And this time they are exterior to my parallel lines, so they're same side exterior. And these angles again are supplementary. And vertical angles are angles that are across from one another, and they're formed by any intersecting lines. And these are congruent. Now, my diagrams are missing tick marks to show my parallel lines, so I'm going to go in and add those now. And once I finish my parallel lines, the summary will be complete and we'll say goodbye. There we go. See you next time. Bye.